I would like to begin by reminding you that way back when we started this unit, you got this handout entitled Topic 4.2 Electric Fields. This handout basically tells you everything that's in this unit, which is basically everything that will be on the test.
Yeah, I did get it.
Let's give it to you.
So number one was to define the electric field qualitatively as the region of space around a charge where a positive test charge experiences force. In other words, you need to know that electric fields exist around charged things.
Oh, and we have to do
I
this.
think you know that. We'll get to that. Okay?
Here,
And you need to know, Riley, that we use a small positive test charge to determine the direction of the electric field, right? So that test charge is going to be pushed away, and that's why we say that objects that have a positive charge have a field that points away from them. You need to know that. And I will ask you a question somehow to see if you do know that. Okay? The second one says to diagram electric fields using lines of force with respect to positive test charges, including single point charges, positive, negative, near two like charges, near two unlike charges, between a single charge and a charged plate, and between two oppositely charged parallel plates. In other words, you need to be able to draw fields. Draw fields. Things like this, negative charge. Things like this, positive, negative. Okay, you need to be able to draw fields. Now, unfortunately, the direction is pretty important, isn't it? Because if you get that wrong, well,
You got it wrong.
you get it wrong, right? There's not a lot of part marks here. I can't really give you marks for showing your work because you're drawing. So please make sure you get the correct direction. Could cost you big, big, big. Okay? There will be several of those. I would think minimum 4, somewhere like that, 4, 5, 6, something like that, where you have to draw various electric fields. So don't blow that one. Part 3, define the electric field quantitatively as a force per unit charge. In other words, you need to know that the formula is F over Q, and it's measured in newtons per coulomb. It's the force per unit of charge, newtons per coulomb. And then the next step is to solve problems using that. Of course, we're going to have some problems with E equals F over Q. You should be familiar with that. Make sure you know how to do scientific notation on the calculator and all those things. You should solve problems for the motions of charges between parallel plates. Well, F net equals FV plus FG. Now that includes both suspended ones, right? So you should be able to solve problems where the weight force is exactly equal to the electric force, as well as when the weight force is greater than or less than the electric force, okay? In other words, one's Devin. See, this is what's on the test, Devin. You should be paying, like, attention to me. This is when the acceleration is 0. This is when the acceleration is either positive or negative, right? And really, those are simply problems that we've done in the past before it just literally turned sideways. It's different names to the forces. You need to now, the next one says, describe a simplified version of Milton's experiment. I will not be asking you the question on the test. I will not ask you to describe the Milton experiment. Would I expect you to know bits and pieces about it? Yes. But I won't expect you to say, this is what Millikan did. That's what the project's all about, right? Okay? So, what kind of questions might I ask about the Milton experiment? You should know that he was trying to do what? What was his goal? Anybody know? Go ahead, Courtney. Find the charge on a single electron. You should know that. Charge on a single electron. You should know that. You should know that he had the force is balanced, right? Sort of like this.
Do we get a cheat sheet?
Absolutely. What else? I guess you should know that he came up with the number. You should know the number. What is the number? You should know that. That's equivalent to 1 Elch. And the very last thing here on the outline says define the elementary charge, that's this, and convert between elementary charges and coulombs. In other words, you have to be able to go from Elches to coulombs and back. Remembering that one elementary charge is 1.6 times 10 to the minus 19 coulombs. So set up a ratio. Right, you either multiply or divide by 1.6 times 10 to the minus 19. Now, in addition to these here, and you can add this to your little, if you've got the sheet out, I'm going to be asking you to describe an application. Describe, DES, yeah. Describe an application. In other words, know how photocopying works, know how laser jet printers work, know how inkjet printers work. I'll pick one of those three. Okay?
Can you just tell us which one?
It'll be one of those three. I'm also going to ask you to solve Millikan problems. Yeah. Solve Millikan problems. Like ones where you have to find the charge on a drop or find out how much the electric field is or something like that, right? Basically using this principle. Yeah. Using this principle, right? Remembering, of course, that you're going to need this formula, D equals M over V. What's the density of oil? Anybody remember? 800. You're going to need that on your test. And you're also going to need the formula V equals, what's the volume of a sphere? Formula. I'll get you started. It's 4/3.
It's 800.
800 is the density of oil. When the volume of a sphere is 4/3, pi r cubed. You're going to need those. Is there anything else that I talked about in the last few weeks when we were solving Millikan problems? We did. We did. I can show you where. Well, I can show you where. The worksheet that has a picture of our friend Millikan on it has those formulas, and you did questions like that.
Don't think I got to.
Okay, so I will give you this time to work on your cheat sheet, get yourself ready. I'm guessing you probably won't complete the test tomorrow. That's fine. We can finish it on Wednesday. Test is tomorrow.
Except the last test.
No, we'll probably have a magnetism one, yeah.
It's a magnetic.
I find